session will be chaired by Professor Mallik, so I will leave it to him and to introduce you. And I understand that your title, yes, it's role of SHM, is slightly different than what was in the program. I think it was misspelled, right? But anyway, I will leave it to the chair to introduce the speakers, and Professor Mallik, please.
Yes, good morning, Professor Wala.
Good morning.
Yeah, so I would like to introduce you today's keynote lecture will be presented by Professor Suresh Wala of Indian Institute of Technology, Delhi, India. So now we can start. It's over to you, Professor Wala.
Thank you, Professor Mallik, and I thank the organizers of the conference for their kind invitation to me as a keynote speaker. So basically here in my talk today, I would be delving mainly on the philosophical side of structural health monitoring, the real life scenario, what we see in the developing countries. And when I say developing countries, I particularly mean my personal experience in South Asia, in India. So very quickly, what we would be covering here is how in developing countries, and for that matter everywhere, what is the role of SHM, potential role of SHM in ensuring sustainability. But then the developing nations, South Asia in particular, we have some issues. We face some issues when we talk of SHM in real life structures. Then we go through what candidate technologies can solve problems, especially in the developing countries. Then here I briefly tell about the Indian Structural Health Monitoring Society, and then we have the concluding remarks followed by question and the answers. So basically this is a study done by the Central Road Research Institute, a premier research body of the CSIR, Council for Scientific and Industrial Research, Government of India. And according to this study, the average lifespan of a typical bridge in India is only 34.5 years. The failures which have happened in India between 1977 and 2017, and what has come out that the leading cause of failure is the superstructure in majority of the cases. Another point, the pie chart below, it might give an impression that the concrete bridges, they are more vulnerable to failure. But thing is that the proportion here, if you can see that 63% of the failures are the concrete bridges, and we have steel bridges about 19% failure. So basically they are in the proportion of the existing bridges. We have more than 75% bridges, they are basically concrete bridges, and only 20 to 25% bridges, they are basically the steel bridges. So this is the normal case from the Indian perspective. So every now and then we see failures happening in India. And if we talk of the year 2024, so it was quite a bad year. At least 15 bridges collapse on our national highways, 11 collapse while under construction, and 4 collapse under operation. So what is the reason for this kind of localized happenings? Because at least 12 of these, they happened in the state of Bihar alone. Whether it's a design issue or construction standards, or in the case of the running operational bridges, is it the operational maintenance problem? So many of the things here in our country, they are not very transparently discussed, and often these things are generally buried. So that is the situation I am talking about. So here the typical issues when I say with developing nations, India in particular, and then we face the problems of bureaucracy here. In general, among the government bodies, government officials, and even the engineers, the understanding of structural health monitoring is very poor. The accountability is often not a pinpointed one. It's very difficult to pinpoint the accountability. Then there is a high reluctance to update skills and adopt new technologies. If there is decision making, it's abruptly taken at the higher level without participation of the ground engineers and personals who are actually involved in the process of maintenance. Then even if it's decided to implement SHM, then the approach is half-hearted. That is, there is always inconsistency in implementing the SHM solutions. So here there are misconceptions. Misconception number one is that it's thought by authorities that our infrastructure is new, our building is new, so it does not require any structural health monitoring. So we can just take it for granted. However, even if the structure is new, it's very important that we perform tests and some basic instrumentation on the infrastructure, whether it's building or bridge, so that we can map the parameters of the building and the bridge, and we can correlate with the design parameters. So that's why baseline is very important. Once we have the baseline, we can always make decisions about what's happening in the building. If the stiffness and if the building is undergoing any loss, any structural loss, we'll be able to correlate very well. But if we don't have the baseline measurements, then after 10 years something happens, we are in dark. We are not able to tell related to the original making of the structure. So here the problem is that the authorities, they wake up very late when there are visible signs, and when there are visible signs, often they find a alibi, and that is they shoot out a letter for structure audit. So here in India, structure audit is the buzzword. They think this is something which can solve their problems. They have no idea about structural health monitoring, how it's different from audit, and what additional information or greater information structural health monitoring can bring. So this alibi works often because the authorities, they find something happening, some media coverage, they immediately shoot out a letter, and then they get excused that we have written to this and this higher authority, higher educational body, and it's up to them. We are waiting for response. So that's the normal way the things happen here. So thing is that the economy is growing, and our union budget, it has earmarked over 140 billion US dollars for infrastructure. So this is only the government budget. Now there are the private players also who are also doing infrastructure projects, private bodies. So we can now understand the way, the accelerated manner in which the infrastructure sector is booming in India. Now, to ensure longevity, uninterrupted performance, minimal downtime, and resilience, it's very important that these must be monitored by using the advanced SHM technologies. So here another irony is that the government and the bodies, they often install SHM systems, but there is no dearth of the number of such systems which have been installed, but they are just lying as they are not utilized. They are not able to give the desired results, either due to poor maintenance, lack of any technical capacity, mismanagement, or the things have been installed, they have been handed over, but the authorities, their technical team, they have not learned and they have not integrated in their long-term protocols. So if we just do a survey, we find a number of such structures in India where the SHM systems have been installed, but they are not being utilized, either due to lack of trained personnel or because of integration, lack of integration, or lack of skilled manpower, or lack of spare parts, or lack of any proper service contracts. So there is no dearth of such projects where huge amounts of money have been invested in SHM systems, but they have not been utilized. So here, as part of our Smart Structures and Dynamics Lab and the Indian Structural Health Monitoring Society, so our motive is to educate and inform the stakeholders that structural health monitoring is not a rocket science, and we can have simple solutions which are pragmatic in nature. So when we talk of monitoring, whether it's a bridge or a building structure, typically we need to monitor the static response, and we have to monitor the dynamic response. Both of them are quite important. Static response could be in form of displacement, in form of strain, and the dynamic response could be in the form of, say, acceleration. So my personal learning from the different number of projects is that here strain, whether it is a static strain or dynamic strain, that offers a very simple parameter from where we can extract the features necessary for taking decisions about the condition of the structure. So when we say strain versus deflection, it's always the strain which has an edge, because absolute displacement in real life scenarios, it cannot be measured. So we have to either rely on tilt measurement, but better than tilt is of course strain measurement, because if we have the strain measurement, we can always correlate it with deflection also, and this is something we utilize for very simple way for obtaining the operational performance check, and also for long-term the stiffness assessment by dynamic measurements. So here for dynamic measurements, we have proposed piezo sensors as effective replacement for accelerometers, which are very expensive gadgets for developing countries, and they are also fragile in nature. So with piezo sensors, we have shown through practical examples that it's possible to carry out operational model analysis and obtain sufficient data which can be correlated with the stiffness of the structure. So here I would just like to bring to your notice, this is a special concrete vibration sensor, a composite piezo cement transducer, which can be inserted in the structure at the time of the construction, or it can be installed after the structure while it's under use, and this can be very well employed to obtain the dynamic response of the structure, especially concrete structures. So it has very good performance, very good signal to noise ratio if we compare with accelerometer, but then the cost is quite minuscule as compared to accelerometers, and we use it very well. So we show some real life demonstrations where we have used the static strain for operational performance check, serviceability check, and the dynamic strain we have used for stiffness measurement through natural frequencies and mode shapes for taking effective decisions of structural health monitoring. So here now I am showing my own house. So I am constructing this G+4 home, and here I have installed the vibrating wire strain gauges in one of the columns to effectively measure the loads ultimately transmitted to the foundations. And here this is another bridge where we show by measurement of the static strain, we can very easily correlate with the actual deflection. So here we measured the strain and we very well correlated it with the deflection, and the results are quite matching in the sense. And through this measurement we found that operationally saying the bridge is not performing well, because the authorities have noticed here some issues, and they have closed the bridge for heavy traffic. But even with light traffic, the deflection and the strain, they are exceeding the prescribed limits by over 3 times. So here, when it's the first level diagnosis, we use the static strain, but for deeper feature extraction, we must do modal or stiffness related parameter checks, and for that purpose also we can use either piezo sensors or similar gadgets. So here in this particular bridge, we use the accelerometers, and using the data from the accelerometers, we came to know that the apparently distressed span, its stiffness is just 65% of the apparently good condition span. So this helped in taking a proper decision. But I also show you the applications where we have used piezo sensors as a replacement of the accelerometers, and we have got very good results. Now here you can see here the sag, apparent sag in the span, and this is the result of this particular span. So here we show you foot-over bridge where we installed piezo sensors. These are the simple piezo sensors available in the commercial market, even in Amazon and other e-merchandise sites. And through these we carried out the operational model analysis, and with this we obtained the first few modes, even the 3D modes including the torsion, we could very easily obtain by this simple technique. And this is another bridge just opposite to our institute, where we use both the piezo sensors and accelerometers, and we could do here a study involving the frequency measurement and energy harvesting. And here this is a joint study done by IIT Delhi and Central Road Research Institute in this 150-meter distance steel bridge. So here we installed piezo sensors, including some novel design. You can see here, this is a novel design which gives us amplified strains, so it can capture very low strains also, which get amplified ultimately. And just under the running traffic, we measured the dynamic strain response, and we could very easily correlate it with the modes of the structure. So I teach the subject of structural health monitoring, and in 2024 I took my class for some basic measurements in the this same bridge. And in 2025 we came with a more ambitious target, that let's obtain the first mode shape of the main girder. So we can see here, these are the piezo sensors which are bonded on the side face of the main girder near the top, and this is how they look. By inserting our hand, we bonded them one day before, and this is the video 1-minute clip which shows how we carried out the measurement of the baseline mode shape of the bridge. So basically now other candidate technologies which which could be useful in the Indian context or for the developing countries are the optical fibers, especially the FBG or the fiber Bragg grating sensors, where they use the principle of the gratings, which act as basically filters. So they filter out a particular frequency, and most of the other light is transmitted, and this serves as the measurement of the corresponding strain which is coming on the structure. So this particular frequency is the Bragg wavelength. So this is a very promising technology because it has multiplexing potential, it has small size, the sensors are non-reactive, it's immune to electromagnetic interference, and there is no problem of decay because our measurements are based on wavelength and not intensity. And now there are solutions, very good high quality FBG sensors are there, which are not easy to get snapped. And other technique which has very good potential is the vision based technique. Either we use a drone with a camera as an artificial eye, which is favorable for AI integration. At least we can map the surface defects. We may not be able to pinpoint the actual stiffness or the residual condition of the structure, but at least the surface defects, the non-accessible portion of the structure we can of course find. And the other is the photogrammetry technique, where we can get the static response or the dynamic response. So these also have very good potential in the Indian context. So when we say what is required for the developing countries is we need trained manpower, we need industry academic joint research, we need an ecosystem where different stakeholders can come together, and we need policy from the point of the government. And it is in this direction that we have formed the Indian Structural Health Monitoring Society to propagate the agenda of and the importance of structural health monitoring here in South Asia. So its aim is to act as a catalyst for the development and implementation of SHM and related technologies, to form an ecosystem, to promote awareness and capacity building about SHM, to promote the dissemination of the state of art in SHM, to represent the SHM profession in India and abroad. So this is the website, and we have different membership grades available. It's open to membership from all over the world, and we are soon going to get the requisite permissions for handling foreign exchange also. So what contribution we have made in this short time is that we have come out with some basic guidelines on SHM, and our document is now being referred. We have come out with basic answers to some of the most pertinent questions: what type of structures they need SHM, what type of instrumentation and sensors they can be used, what parameters should be monitored, what should be the measurement schedule and sampling interval, and how report should be generated. These basic issues we have covered here. So the path forward for developing countries in concluding remarks is that we need to overcome bureaucracy, and there is definitely corruption also. So here manpower comes cheaper as compared to the expensive autonomous hardware. So here we have to very carefully select the technology, keeping this in mind, because sometimes my personal experience is that we have suggested very high-end SHM solutions, and after a couple of months the client says that we are unable to decipher them. So we have to make use of the locally developed technologies, and we have to test them here in different structures, then only we should proliferate. So here most expensive so-called technologies that may not be a working solution, so we have to overcome the bureaucratic hassles and adopt something which is economical and favorable for the Indian conditions. So in this endeavor we have already started startup as part of our institute, our institute promotes startups in new technologies. Our government also promotes. So we have started this startup named Sanrachna Prahari. So in English it means basically guardian of the structure. So this has become operational, and it's basically helping the government and the private agencies in choosing and implementing structural health monitoring solutions. So with this, I would like to now thank again the organizers of the conference for their kind invitation, and now I am open for question and answers. And I thank Professor Piotr Munzeta, Professor Mallik, the chairperson. And of course, I cannot forget Professor Punendu Das for his kind invitation. So thank you very much.
Thank you, Professor Vala, for your nice presentation. Now I open this session for question. Any question from the...
Hello, my name is John Huxtable. I work for DEWESoft, who provide sensors and software. And I'm not going to be an annoying sales guy, but I noticed that you have identified many gaps and a path to improve the uptake of structural health monitoring in India. I think that the path and the gaps that you have identified are the same as the gaps here in the UK. You need to have the interaction with academics, you need to have the right people, and it's a real challenge to change the mindset, I find.
Yes, I totally agree with you, and I'm very happy to find someone who echoes the same thought process, and especially I'm sure if you have issues in UK, then you can imagine how the problems are, what kind of problems we face in countries, the South Asia and other developing countries. So thank you very much for your feedback.
I was also very interested in these piezo sensors. I imagine that as your coaxial cable gets long, that you may experience challenges with the signal quality, or do you have some kind of amplifiers that are close to the patches? I was interested really on the instrumentation side for my own understanding.
Yes, this is a very good question. So usually we have done a lot of testing with these piezo sensors. So what we find is up to 50 meters, we don't encounter any problem if we are using coaxial cables. So this bridge which we handled, it was 115 meters long, and at the midpoint we had the controlling station. So our typical wire length was close to 50 meters, and we did not find any issue. But of course we also have here solutions. The wireless are these hybrid solutions which can have a system very near to the piezo, and it can then transfer the data in the cloud. So those kind of systems are also there, we can use with the piezos. So piezos are just like they give out the voltage signals just like accelerometers. So whatever we can do with the accelerometers, we can do same thing with the piezos also.
Thank you.
Yeah.
Welcome.
Any other questions?
Welcome. Professor Vala, Basuraj, thank you for a nice presentation. I just wanted to ask regarding the artificial eye that you have mentioned for drone-based monitoring. Could you tell us more about some of the projects that IIT Delhi may have carried out with drone-based monitoring?
Drone-based monitoring we are not doing, but our collaborating agency CRRI is doing a lot of work in the UAV assisted technology.
All right, thank you.
Thank you.
Yeah, okay. So Professor Vala, before we conclude, I have a small query. So have you also, you have shown strain monitoring. Have you also compared, communicated with the structural damage with those strains correlated?
Basically, the main use of the strain in the hybrid approach which we follow, static strain and dynamic strain. So static strain is the first level of assessment, because strain is something it's used for operational serviceability check or operational performance check, because if there is any heavy loading or if the structure undergoes a significant loss of stiffness, then this would be the first indicator that something wrong is there. And once this is showing that yes, the strains are within the limits, then it reinforces that yes, right now more or less at first level there is no issue with the structure. But yes, this is only first level, so if we want to get hold of the actual stiffness of the structure, we have to go deeply and we have to make use of the dynamic measurement. So basically we are using both the static and the dynamic measurements in a hybrid fashion, so that we get information. So if we are only using the static strain, then we can only set up something like threshold base indicator or threshold base green, orange, red kind of button. But beyond that, if you want to go, then we have to do more detailed testing.
Okay, thank you very much, Professor Bhala, for your nice presentation.
Thank you.
And we appreciate your efforts. Thank you.
Thank you very much.